Record. Okay, perfect. Let's get started. Let's get started. Welcome everyone. One second. Let me turn to my camera. Okay, perfect. Welcome everybody. Are you all able to hear me, see me, all good in the chat? Yes? How are you doing this morning? Perfect. So welcome everyone once again to day two of GenAI Mastermind for Engineers, where we take you to the world of what's happening in the world of technology, how AI is evolving that. And we covered a lot of things yesterday, right? Perfect, perfect. Let's go in the chat. Let's go in the chat. Let's quickly get into it. Type and get. Let's go. Let's quickly recap what we looked at yesterday and how we are going to get it done today. Give me one quick second. Sharing my slides now. Okay, perfect. Perfect. Looks like it. Perfect. So once again, yesterday we covered developer productivity and AI agents. What exactly we saw is how do you interact with generative AI models? What sort of models exist? And what are their advantages and limitations? At the end of the session yesterday, we also looked at how do you work with AI to generate code. We looked at Cursor, we looked at Cloud Code, we understood how they are able to do it. At the same time, across the first 3 hours of the session, we went very deep into what are the use cases that developers or tech professionals specifically can adopt AI and make their workflows or work better, faster, cheaper. Do you all remember this term, better, faster, cheaper? In the chat, better, faster, cheaper? Better, faster, cheaper. If you're all able to hear me, see me clearly, okay, people people trying to make their own short forms, which is great. We have seen the chat. Oh, perfect. So today what's going to happen, interestingly, so everything that we understood yesterday has set a great base for what's coming in today, right? In next 5 minutes, we are going to jump into agentic AI frameworks, right? What exactly are agentic AI frameworks? That's what we'll uncover. How exactly these systems function? That's what we'll cover. The use cases of agentic AI frameworks, how sort of are what are the things that you should keep in mind when you build them, and we will also see live projects, which means things that you can look at, things that you can adopt in your own organization, agents that exist today, which you can use and build for yourself, and the kind of use cases that it solves for, so that you have complete understanding of when you work with agentic AI frameworks, what kind of problems that you can solve with it, how do you go about building it. Now, that's what's happening in the first session. After that, we'll take a quick lunch break and we'll come back. And after the lunch break, we'll look at how do you orchestrate these agentic AI workflows and how do you work with multi-agent systems. And at the end, how do you give agents ability to take action, which is through MCPs is what we are going to cover. If all of these terms sound alien to you, I think for a lot of you it may not be, but for some of you, if they are, hang around till the end and everything will make sense, as I said yesterday as well, right? Make sure we make a lot of notes, as I said yesterday as well. To get these outcomes, you must commit to being present in the session, engage in the demos. There are going to be incredible demos that are coming over today in the first half and the second half as well. And there's a dedicated question and answer time where you can ask questions. Meanwhile, when the mentor is teaching, there's an AI companion on the Zoom chat which you can click and you'll be able to chat and have a question answer like a model as well. And the AI companion knows everything that a mentor is speaking and I'm speaking. And make sure you take down all the notes. Once again, reminding everyone, if you are joining the first time and today, we are all students for these 2 days. Forget you have what kind of experience do you have. Forget the background that you come from. Just remember what can you leverage the most from every session. Okay, are we all students in the chat? Yes. Type in students, and we'll quickly, without wasting much time, we'll get right into the session. Students in the chat, yes. Perfect. Perfect. Let's welcome our mentor for the day. The first mentor for the day who's coming in, one of the best ones that we have. Okay, okay, let's get into it. Perfect. As I said, 2 days of focus. Today is day two, and we'll make sure that you're ahead of 90% of tech professionals around you. If you are someone who's looking to transition to tech, you'll understand what's exactly happening in this world. And if you're already someone with 5 to 10 to 15 years of experience in tech, you'll exactly know how to lead further with help of generative AI with this today's sessions. And for that, let's welcome our first mentor for the day. Let's welcome our first mentor for the day. Okay, are we all set? Let me just quickly check. Perfect. Can we type in welcome Ishan in the chat? Can we all type in welcome Ishan in the chat? Can we? Yes? Got it. Ishan is an ML engineer at Adobe and has worked at multiple startups before. And he's someone who's doing incredible things at Ruby. I'll leave Ishan to talk about that very quickly. He has helped up close to multiple thousands of people learn generative AI, implement in their own organization, and he keeps on consulting as well. And he has helped a couple of thousands of engineers adopt AI, work with them, make their workflows better, faster, cheaper, specifically with help of agentic AI frameworks. And today, the next 3 hours, your mind is going to be blown. So I hope that you have had a heavy breakfast. I'm seeing a lot of energy come in as well. Ishan, can you do a quick check if people are able to hear you, see you?
Hello everyone, how are we doing today?
Got it. Folks, are you able to hear him, see him very clearly? Perfect, perfect. Welcome, Ishan. Thank you so much for joining us this morning once again. I think always, lovely to have you. And yeah, I think the crowd is up for a ride for the next 3 hours.
Yeah, let's get started. Thank you for having me.
Folks, I'll see you. I'll see you. As I said yesterday, I'll keep on coming between the sessions, try to summarize things and give you some action items. For now, Ishan, over to you. Thank you so much. I'll see you.
Thank you. Hello everyone, my name is Ishan. I will keep my intro for towards the end of the session. Let's get directly started with it. So, what is it that we are going to cover today? Okay, this is going to be a completely hands-on session. Most of the session, almost entirety of it, other than the first 10 minutes where I will explain you a couple of things, we will actually be coding throughout. Okay, so that is going to be there. We will do multiple different projects. We'll start with something very simple, like a single agent project, and we'll go to multiple agents. I will also show you how you can run agents in parallel, what are some different types of agent architectures, and so on. So all of this we are going to cover. We are going to use a Python-based framework, which is called as Crew AI, which we will be using to create all of these different projects. It is okay if you have never ever programmed in Python. I'm going to explain each and every, you can say, parameter, function, everything that is going to be there. And so that is all fine. Okay, so don't worry about that. And yeah, in between, I will keep looking at the chat, but I usually take very few questions during the session because we already have a dedicated time at the end. But I do take questions which I feel are resonating with a lot of people. Okay. And yeah, we will come to that, why Crew AI and instead of other frameworks and so on and so forth. But folks, are we ready to get started? I have a ritual to get started before every session. Is that O keeps telling you to not spam the chat, and I come and I say all that you should be spamming the chat. So drop in a fire emoji in the chat, folks, and show me the kind of energy that you have for the next 3 hours. Drop in a fire emoji. Show me that energy you have. We are going to require a lot of energy. It is a very intense session, and I need your absolute focus for the next 3 hours. It is okay if you have never built an agent, if it is okay if you have never programmed in Python. If you just keep your focus for the next 3 hours, you are going to gain an extensive amount of knowledge. And At the beginning itself, I will mention whatever code you are going to see here today will be provided to you once the mastermind ends, not the session, but the mastermind ends. Okay. So please do not come to me in between and asking questions about where is the code, where can I access it, how can I code it. All of that will be provided to you. Okay. With that, I believe my name is Shan and we are ready to go, folks. Okay. Quickly sharing the screen. I will keep on turning on and off the chat in between. Okay, whenever I ask you all to do something. Yeah. Okay, cool. I don't have permissions to share sound. I think there are multiple people who are allowed to share screen.
You can
I can now. Thank you. Cool. Folks, if my screen is visible, everything is audio is clear, video is clear, everything is good. Just type in good in the chat. Just type in good in the chat. You're able to see the screen, listen to me. Everything good? Cool. Also, the folks asking about the AI companion, it takes a while to get started, folks. The AI companion cannot get started without any context, right? Session hasn't even started yet. So you will see the AI companion. Don't worry about it. Okay. All of you have gotten a slight taste of what is going on in generative AI, what are some developer productivity tools, what are agents, and so on. And today we are going to, I will just give you a quick 5-minute review of what exactly an agent is, what does it look like, what is an overall architecture, whichever, regardless of what framework you are using, you will be able to go with it. Okay, so here is what you should be knowing. And if you are clear about what I'm going to tell you now, yeah, things will become pretty straightforward for you. Okay, cool. Let's get started. First of all, let us understand what is an agent, okay, and not just what is an agent, what are the most important components in an agent. This is regardless of whichever framework you are using. This is regardless of whether you are creating your own agent or doing anything. Okay, so this is going to be extremely important. That now, if you think about an AI agent, the equivalent of an AI agent, can someone quickly tell me in the chat what is the equivalent the real life equivalent of an AI agent in the world? What do you think is a human like equivalent of an AI agent in the world? What do you think? Quickly tell me in the chat. What do you think is a human life equivalent? Whatever comes to your mind. Whatever comes to your mind, just let me know. Okay, I see people typing neural network, API, bot, travel agent, brain, arms, legs, dedicated worker. The correct answer to this is the equivalent of an agent, of an AI agent, is a human body. Okay, it is a human body. So if I am saying that this is my agent, let's call it agent number 1. This is an equivalent to a human body. Okay, but this human body does not have a brain of its own. So what will be the brain to this agent? Quickly tell me in the chat, what will be the brain to this agent? Correct. The LLM is going to be the brain to this agent. Okay. The very first thing that you all have to be clear about, that an AI agent, okay, in its own is just the human body. It does not have a brain of its own. We will have to provide it with, okay, we will have to provide it with an LLM as its brain to function. Okay. Now every AI agent, yeah, has to do something which is called as a task. Okay. Let us call this task 1. So let us say agent 1 is doing task 1. Okay. So there is a user. This is our user. Okay. Who comes to our agent. This agent has access to an LLM and this agent can perform a task. And based on this task, we get a final response. Okay, this is what it is basically about. Okay, but here are two more very important components that actually make an agent like different from. How does an agent different from an LLM? Okay, what is it that makes it so special? Let me give you a very simple example. How many of you here have used any of the AI coding tools? And if you have used, like, what is the tool that you have used? How many of you have used any tool to code with AI? Okay, I see. And which one? If yes, which one? And if you haven't used, just type in no in the chat as well. That's fine. Okay, I will get a sense. I see chat. Okay, chat GPT, N8N is not exactly an AI coding tool, but okay. Cursor, Lovable, Copilot, Bolt, Gemini. Do you know these are agents or LLMs? What do you think? Whatever is being mentioned in the chat, are these agents or LLMs? Correct. These are agents. Now, what is it that makes it an agent? Most of these frameworks that you're talking about, tools that you're talking about, have a capacity, okay, have the ability to actually execute the code which the LLM is generating. Okay, so there is an LLM which is generating some code for you, which is generating the front end, back end, whatever you are doing, depending on level of course, all of that. So this LLM is just generating the code, but at the same time, these agents have the ability to execute and check whether your code was correct or not. Agreed or not? Type in agree in the chat. Okay. Is it the same behavior? That regardless of whichever agent you are using, just type in agree in the chat. This is what is happening. LLM generates the code and your agent can actually execute the code or actually apply that code into your actual code. Because if you are using Cursor, let's say if you're using GitHub Copilot, you ask it to make a certain number of changes, it actually goes and edits those files, okay, on its own. So these features that you're looking at, these features which you have already experienced, okay, are called as tools. Now, tools is what makes agents special. What can be a tool? Something as simple as giving the agent the ability to web search. I'm sure all of you here have used ChatGPT, Perplexity, or any of these tools, and there is an option to web search. Okay, so there is actually, if I just open up ChatGPT here, okay, there is a plus button. Okay, in more, in plus button more, and you have web search button available over here. What does this web search do? It allows ChatGPT to search the internet for your whatever queries you have. Okay, so that is an example of a tool. Whatever you see creating an agent, everything is an example of a tool. Now, something other than that, let's say you have an agent which can book tickets. So being able to run that API which can book a ticket is an example of a tool. Let's say if you're using Cursor, Claude, or anything of that sort, being able to execute code, and all of the other things, other than actually generating that code, actually generating what is required and all, is coming under tools. Okay, folks, this is extremely important that you understand. An LLM cannot execute tools on its own. Okay, so here the model that you see, GPT-5 Thinking Mini, does not have the capacity to search the internet. There is a system which exists which allows ChatGPT to search the internet, provide the relevant context to these LLMs, whichever are mentioned over here. Okay, so LLMs cannot search the internet, LLMs cannot execute tools. It is actually the agent, it is actually the entity, the agent, which is executing these tools and getting relevant information to the LLM. Okay, is this clear to everyone? Type in clear in the chat. Do you understand this difference that tools are not being executed by the LLM? The LLM just can't. Okay, it's like saying, hey, my brain can just go out and buy vegetables from the market. It can't. Your body has to be there. It is the exact same thing. Okay, but there is another extremely important thing. Okay, there's another extremely important component that comes in terms of agents. Can someone tell me in the chat what component I'm talking about? There's some extremely important component which is there. Can someone tell me quickly what I am talking about? Correct. It is called as memory. Okay. Now I will get into the details of the types of memory and all that agents can have. But what is memory? And I'll create a different page for that. But memory, as of now, you can think that, let's say, okay, let's say for example, and this is actually one of the agents that we are going to build today. So in amongst the multiple agents, we are going to build a DevOps agent. We are going to build our stock trader agent and all of that. So let us say you have a stock trading agent. Okay. And this particular agent, you can give it the name of any stock and it can tell you whether you should buy this stock, hold this stock, or particularly sell this stock, okay, based on whatever time and news and all everything is going on. Okay. Now, do you all think, you can type in important or not important in the chat, do you all think it will be very important for a stock trading agent to have context of the previous trades that it made, what it thought, whether that trade went right or wrong, if it went wrong, why it went wrong? Do you think it will be important? Why do you think it is important? The agent is the same, the LLM is the same, the instructions will be the same, but still, why do we need the previous data? Why do we need memory? Correct. To understand the context better. Okay, to understand the context better. That also comes under a little bit of context engineering instead of just prompt engineering, which basically specifies the better your context, the better your outputs of your agent of your LLM are going to be. Okay. So we want to give it as much context so that the agent also understands that, hey, these all places I went wrong, these all places I went right, and so on. So that second thing, important thing, is going to be memory. Now, this memory can be of multiple different types. Okay. Number one is called as short term. Okay. What is short term memory? Short term memory is the most recent execution of my AI agent. Okay. So let us say I have a stock trader agent and I try to trade 10 different stocks from it. Okay. Stock number 1 to stock number 10. The most recent execution which I did about stock number 10, whatever details are around that will only be saved in the short term memory, which is going to be the most recent. Okay. Second one is called as a long-term memory, which has all the previous informations. So if we have, let's say, traded on 10 different stocks, it will have all the 10 executions with us. And I will show you what the internally the memory looks like, what exactly is being saved and so on. So long-term memory will basically have all of the previous executions of your agent. Short-term memory will only have the latest execution of your AI agent. Okay. So this is basically how memory is classified. You can store this in a vector database. You can store this in SQLite database, whatever you want. CrewAI provides some of this in as well. Okay. So moving on. This is what overall an agentic architecture looks like, where you have a user. Okay. So where you have this particular user, he gives a task to an AI agent, which has access to an LLM as its brain. This agent also has access to a set of tools which it can use to complete the task, and memory to keep track of whatever executions it is doing. Based on that, it can perform a particular task which it has been set to do, and finally it generates a response. Now, here is the interesting thing. You can have multiple agents in this architecture. Okay. So I can literally do this, that I can have an agent number 2 as well here. Agent 2. Let me give another LLM to this agent. Okay. We have agent 2. I've given it another LLM. For agent 2, I can create another task. Let's say it is called as task 2. Agent 1 does something, goes to task 2, and finally we are generating our response. Okay. So what did I do? If I zoom out a little over here, you can see we have a user who gave a task to an agentic system. Okay. This agentic system, instead of having just one agent, has multiple agents now. Each agent has its own LLM. Each agent has its own task that it has to perform. Okay. For example, let's say you are in an engineering team. You will have a separate engineer for front end, you will have a separate engineer for back end, you will have a separate QA tester, you will have a separate DevOps engineer, and so on. Similarly, in this case, I will have a specialist agent one to do particular task one, which it specialize into. Let's say this is a front-end engineer task, front-end engineer AI agent. Its task is to generate the front end of the website. Let's say this is a QA tester agent. Agent number 2 is a QA tester. The task will be to test whatever changes have been made by developers. Based on all of that, it can generate a response, and both of them have access to a set of tools and memory. Okay. This entire setup that you are seeing over here, this entire setup, because we have multiple agents together, okay, which basically is a crew of agents. Okay, so this is, let me type it over here. Okay, which is basically a crew of AI agents. Hence, the framework that we are going to use is called as Crew AI. What is a crew, folks? What is a crew? Quickly tell me in the chat. A crew is basically a set of people who come together to perform one particular, let's say, larger objective. And in that team, everyone is actually specializing in something to do. Okay. So what you see over here is a crew of AI agents, which is coming here to perform a task given by the user. This is multiple agents, multiple tools, multiple groups, multiple memory, and so on, and getting the response. Hence, this framework is actually called as Crew AI. Okay. Is everyone clear of this diagram? Okay. Is everyone clear of this diagram? Have you all understood till here? Okay. Type in clear in the chat. Type in clear in the chat, folks. If you have understood, this is the most important piece. And we are going to have very little theory post here. It will be all execution, and we are going to see code continuously. But it will be extremely important that you all understand this over here. Is this diagram clear to everyone? What is an agent? What is an LLM? What are tools? And when we implement that, thing will become more clarity to it. Okay. Awesome. Cool. Moving ahead. Okay. The first agent that we are going to build here today. 1 second. So the first agent that we are going to build here today, is called as a conflict detector. What it will do, we will give it a sentence. All of you must have heard of something called as hallucination in LLM. So can someone tell me what is hallucination in an LLM? Can someone quickly tell me in the chat what is hallucination in an LLM? Inaccuracy, generate same response, pattern same, producing fake results, inaccurate output. Is it okay to say that hallucination kind of also means that it generated something which actually doesn't make sense given the context? Yeah. Overall, there are of course more nitty-gritties and nuances to it, but overall, we can say that it is definitely an inaccurate response, and a lot of time that response doesn't even make sense. Correct. Correct. Okay. So we are going to give it a sentence, and some these sentences have been generated by an LLM. Some of this is hallucinating, some of this is not. Okay, this is actually a very big problem. How do you detect something of that sort? So we'll give it a sentence. We will have an AI agent over here. Okay, we will have an AI agent over here, and this agent will tell whether there is a conflict in the sentence or no conflict. Conflict basically means the LLM is hallucinating. No conflict basically means the sentence is perfectly fine. There are no hallucinations. Okay, so this is the first example I have knowingly chosen to be pretty simpler. From the second one, it will get into like multi-agent stuff and all. But this one particularly focuses on helping you understand what are the different parameters and all that we set up. Okay, so let me just share this with you. This is what we are going to. This is a Python based framework. It's an open source framework. that we're going to use today. I've dropped it in the chat as well. What does it I mean? What do I mean by an open source framework? You can just do Crew AI GitHub, and you will find the entirety of the code base available on GitHub. Okay, I will drop this as well in the chat. And if you want to look at the documents, you can just do docs Crew AI, and this will have the relevant documentations. Okay. Now, folks, why am I using Crew AI first of all, and other than any of the other frameworks? There are a bunch of different frameworks. There's something like LangChain. So we have LangChain. Similarly, we have in the same family we have LangGraph, okay, which is another agentic framework. Yeah. Products, if you go, you can see like LangChain, LangGraph, all of that. LangChain is particularly useful to create sequential kind of agents, like where you have one agent, then some agent number 2 does something, agent number 3 does something. LangGraph is particularly useful when you want to orchestrate, have one agent which can orchestrate multiple different agents, run a bunch of things in parallel, and so on. Another very good framework is the OpenAI Agents SDK. If you want to remain within the OpenAI family, we put all of these links in the chat. Want to stay within the OpenAI family and utilize their web search and all of that, you can just go with the Agents SDK. It is available in Python as well as TypeScript. A lot of these agentic frameworks are actually available in Python as well as TypeScript. Okay, but why Crew AI? So I have actually been teaching the similar sessions for over 50, 100,000 people now with Outskill itself. And I've tried that all, LangChain, LangGraph, OpenAI Agents SDK, and we have like more advanced frameworks like DSPy and all as well. So we came to a conclusion that first of all, the documentation and the syntaxes of Crew AI are extremely easy to understand. Okay, it has been written very, very well. And secondly, people are able to relate to it more because the syntaxes are easier. In terms of LangChain and LangGraph, if you are using it to begin your journey for the first time, it becomes very hard for people. Okay, most of the things that you can do with LangChain or LangGraph can be implemented using Crew AI as well. Most of the things that can be done with the OpenAI Agents SDK can also be done with Crew AI. If you become an expert in any of these agentic frameworks, you will be able to translate your knowledge to any of the other frameworks. Okay, so it is not going to be that you have to learn everything from scratch. Okay, so that is there. Let me actually quickly take you through the documentation. You can just come to the docs link which I've shared. In this, you have introduction, whatever installation you will require. You can just go over, watch this video. And if you have Python or UV already there, do they have? Okay, so they will require UV installation setup. In my GitHub repo, I will give you pip installation setup as well. Okay, so you will, it's like you will have to run just this much once you have UV installed. Okay, so this line, depending on if you are using Windows, you will have to install this. If you are using Mac, you will have to install this. This is UV installation. This is the package manager basically. So just run this, these 3-4 lines, and your Crew AI will be set up. Okay. Now, this documentation has been really well made. Like, for example, there are multiple different guides which tells you how to create very good agents. It has multiple different concepts on agents, what are tasks, what are flows, what are knowledge graphs, all of these things. Then it also has MCPs enabled. So you can literally have MCP servers within Crew AI. It has a very detailed documentation on the kind of tools and all that you can use. So in terms of Crew AI, you can have something as simple as being able to read a file, folks, is also a tool. Okay, so if you've ever gone on ChatGPT and uploaded a PDF, the LLM does not have the capacity to read that PDF. There is actually a tool which is available which converts the text, which actually fetches the text or parses the text from that PDF and gets it to the LLM. Then something like web scraping, all of these are tools. Databases, AI, machine learning integrations, all of these are different tools which are there in the tools section. And in terms of observability, observability basically means that how is your agent performing, how many tokens is it using, how much is it costing, is it failing somewhere, are all the stages working correctly, and so on and so forth, come under observability. So how you can do all of that is available over here, and there are a lot of learning resources. Okay, based on this, how many of you think that this is actually a very, just type in docs in the chat, if you think these are like very well made docs, and with everything you have the API reference and all is well. The examples are very extensive over here. Game builder, recruitment, matching profile. In terms of flows, also multiple things are there. Okay, and how many people do you think are involved in actually building such a documentation? It's a very comprehensive documentation, and CrewAI is pretty famous actually. It's 40,000 stars on GitHub, so it's very active in terms of how much is being used. How many people do you think are building this documentation? Just give me a number: 5, 10, 15, or 20, whatever comes to your mind. Okay, I see 40,000. Seriously, man. In in terms of like quality of documentation, let me show you the documentation for LangChain. Okay, this is what the LangChain documentation looks like. It's a little hard. First of all, you can find these over here. The agents models are given over here, but not exactly a lot of examples, and a lot of important things actually come towards the end. So it's not very friendly even to pass by it. Actually, folks, this entire documentation of CrewAI has been built by an agent. Okay, so CrewAI has its own AI agent which builds this documentation. So that is actually one of very core applications of an AI agent, that you can have this entire thing automated. So whenever something is actually changing in the code with any release, CrewAI can pass through any of that and keep updating it. Now, when you go through the documentation, you will feel that damn, this is actually created with AI. It is very neat, very clear, and there are no people involved in building this. How do I actually know this? The founder of CrewAI actually told it in one of his talks, that this entire thing is just managed by an AI agent. Okay. Now, if you see this diagram which is there, which I actually explained you all right now for CrewAI, that you have an agent with LLM, agent with LLM. It has access to certain set of tools and memory, do task and final outcome. This diagram is taken actually from here. Okay, so now folks, are we clear why we are getting started with CrewAI? Okay, let's get to it. Okay, cool. Let's get to it. Now this is going to be our first agent. I will go pretty slow in the first one, ensuring that you all understand the different syntaxes and all. We will have a sentence, we'll go to an AI agent, and it will tell us whether there is a conflict or no conflict. Okay, let us first see what will that look like. So I'll just run it for you first, and then we will discuss exactly what everything is. Okay, so first of all, folks, is the font size okay, or do I need to zoom in? Just type in okay or zoom in. Is the font size readable to everyone? Okay, awesome. I'll just zoom it in a little. I think a few people are asking. Yeah, I think now it should be perfect. Cool. Quickly look at this sentence. Quickly look at this sentence. Okay. After a long day at office, I was going back home in the late evening. After a long day at office, I was going back home in the late evening. Then I met my friend on the way to the office. Do you feel there is a conflict or no conflict in this sentence? Just type in conflict or no conflict based on whatever you feel. After a long day at office, I was going back home in the same late evening. Then I met my friend on the way to the office. Just type in conflict or no conflict. Let us see what our agent believes. So I can just do python main.py, which is the name of this file. I can click and enter. The agent is running. We have an agent called as critical thinker. Is telling us that hey, there is a conflict in the sentence. Why is there a conflict? Why is there a conflict? Without any additional context, we're just focusing ourselves to what is available over here. Is that if he was actually going home in the late evening, then he met his friend on the way to the office. These two sentences together do not make sense without any additional context. Okay, let us get a different sentence. Let's say this one. Okay. I love to travel to new places and explore the culture and food of the place. Tell me, conflict or no conflict? I love to travel to new places and explore the culture and food of the place. Let us see what the agent says. So I have commented that out, uncommented this. I'm running python main.py. And I'm using cursor, by the way, as an ID. You can run this in anyone. And it says no conflict. Okay. So similarly, you can pass on the other sentences as well, and it will be able to tell you. So how do you build such an agent, and what are the components that you will need to build such an agent? Okay. So first of all, let us define the agents. We will require only one agent for this, which we are calling as the thinker agent. Okay. Here is how you define an agent in Crew AI. First of all, to run these examples, I'm using the Open Router API key. You can run the same examples with an OpenAI key or anything. What is Open Router? Open Router basically gives you an option that you can use the same API key and use multiple different models from the same. Okay. So ideally, if I am buying, let's say, an OpenAI API key, I can only use OpenAI models from that, like GPT series. If I'm buying an Anthropic API key, I can use only the Claude series of models. But if I'm buying an Open Router API key, I can use the same API key to run 500, like about 400, 500 different models, and ranging from like GPT, Claude, and so on and so forth. Okay. So yeah, that is where it is coming. So to define an agent in Crew AI, you will need two things: the agent and the LLM, which it has. Okay. So in this case, from Crew AI import agent, and from Crew AI.llm import LLM. I have a different file over here which is called the .env. This has my API keys. Okay, so in that env I have written open router API key is equal to whatever my API key is. Okay. Now to define the LLM, you will require a couple of things. First of all, what is the model that you want? So this is a simple task. So I'm just going with the OpenAI's GPT-4o model, which I'm sure a lot of you might have used. Then I will have to pass in the API key for this model, which I am using os.getEnv. So whatever value I have set in the Open Router API key in this .env file, it will be populated over here. Then I will change the base URL to the Open Router because it defaults to OpenAI API. Okay. Now I will add a temperature parameter to it. What does temperature parameter do? The higher the value of temperature, the more creative your model will be. The lower the value of temperature, let's say closer to 0.1, the more definite your model will be. Maximum number of tokens is how many tokens this particular LLM can use, and timeout is basically what is the maximum amount of time this LLM can take to respond. If it takes more time, we will just end the LLM call over there. Okay, so what all we have taken? We've taken the model, which is the OpenAI GPT-4o model. We have passed the API key. We've passed the base URL as the Open Router base URL. The default for this is OpenAI. So if you are using the Open Router API key with OpenAI API, it will not work. It will give you an error. If you want to use the same setup with an OpenAI API key, you will just have to comment these two lines. Okay. Yeah. You will just have to comment these two lines. You will have to write API key is equal to, yeah. Okay. This will be done. If you want to run with Open Router, just do this. If you want to run with OpenAI, just do this. Okay, so that is what it is. Cool. One second. Yeah. Yeah. Cool. The next part after this, temperature, you all got it. If you want to the model to be more creative, set it at a higher value, more definite, set it at lower value. What are tokens and how is this basically calculated? So if you go on, let's say OpenAI tokenizer demo, yeah. So there's a very good link which you all can actually explore, which is the OpenAI tokenizer. What is the tokenizer? See, these LLMs cannot ingest sentences at whole or like words in whole. So they have to actually break these down into multiple smaller parts. So if you are using, let's say, GPT-4o model, how many parts is it breaking it into? So for example, the fundamental part of an English sentence or any sentence in general is the word. So similarly, the fundamental unit of any input to an LLM is the token. So if I'm writing a word like happy, okay, how many tokens is it? Just one token. The color basically shows it. Single color basically means it's a part of one token. Okay. If I write it, I am happy today, you will see that 4 different colors are over here. So you can figure out that, okay, the model is actually considering every word as a single token. Okay. So if there are 4 tokens, which means I can use 4 words to answer this, but it is not always necessary that one word is equivalent to one token. There are a lot of words which can also be 2 tokens, 3 tokens, 4 tokens, and so on. What does that look like? For example, if I've written happy, it is telling me that, hey, happy is 1 token. If I make it unhappy, it becomes suddenly 2 tokens. So un is being considered as a token, happy is being considered as a token. Another example, if I write possible, it is 1 token. If I write impossible, it becomes 2 tokens. Okay. So similarly, as a thumb rule, you can think of, if I have 100 words, number of tokens of usage will be 1.5 times, which is about 150 words. Okay. So that is the token limit, and timeout is basically, this is in seconds. So within 2 minutes, okay, which is 120 seconds, if the LLM does not respond, I will end the call. Okay. Now to define the agent, what we have done from Crew AI, we have imported agent. Okay, and there are a couple of parameters that you will have to set for running an AI agent. The number one thing is the role. Who is the AI agent? The agent does not know what it's supposed to do. The agent does not know what it is created to be done. It is your responsibility to make it a specialist in his job. It starts with you telling him, hey, who are you? So we are telling the agent that, hey, you are a critical thinker. Secondly, goal. Goal means, what is this AI agent supposed to accomplish? In this case, analyze the text and identify if there is any conflicting information within it. As I said, every agent will have an LLM of its own. So this agent also will be passed with an LLM of its own. The LLM that we are using is the OpenAI GPT-4o model. And finally, backstory, which is making the agent more specialized. Just saying you are a critical thinker is not enough. It's like I'm just saying that, hey, you are a front-end engineer, but what is my tech stack? How many years of experience do I have? What kind of front-end have I built? All of that kind of comes in the backstory, which makes you more of a specialist. So in this case, I write, you're a critical thinker who understands details very well and an expert negotiator. You can identify conflicting statements and information in the given text. Okay. So we have set the role. Who is the AI agent? We've set the goal. What is this agent supposed to accomplish? Which LLM it can use to accomplish this task? And some more backstory to give this agent more personalization and make it more concrete. Okay. So this is it. If you have understood the definition of an AI agent in Crew AI, just type an agent in the chat. Quickly reviewing what we did, we just imported agent and LLM from Crew AI. In LLM, I've defined the name of the model. I've defined that I want to use it from via OpenRouter API key, set a couple of more parameters, and to define the agent, I've specified who is the agent, what is this agent supposed to accomplish, which LLM it can use, and finally the backstory to it. Okay. Quickly type an agent in the chat if you have followed through it. Once we go through multiple different examples, a lot of these parameters will start, picking up with you. The first time it takes time. But the first time it takes time to get used to it, get used to the syntax, especially if you're doing it in Python and if you're not very familiar with Python, so that is fine. Okay. You can do this in any IDE. You can do it in Google Colab. You can do it in VS Code. Anything. Cool. Now, based on this diagram, okay, we have an agent and we have an LLM defined. Okay, and we will have to define a task which specifies in more detail what this agent is supposed to do, how it is supposed to complete this task. So within the same folder, I have a file named as tasks.py, which just defines the task which the agent is supposed to perform. In this case, from Crew AI, import task, and the agent, it will also require the agent which we have defined here, which is named as thinker. So from the agents.py file, I want to import the thinker agent. So from agents, I do import thinkers, agent is imported. Now for the conflict task, naming it as a conflict task, the description will tell you in detail on what this agent is supposed to do. Find if there are any conflicting statements or information in the text, and we pass in the text. Okay, so whatever text you are seeing over here, where what is actually being passed to it was being passed here in the text. Okay. Expected output is also something which you can set over here, like a respond with a conflict or no conflict. Just like I gave you all the tasks that in your chat window, type in either conflict or no conflict. Okay. So similarly, I can set the expected output of my agent as well. I could have just set it as true or false. I could have just set it as 0 or 1, whatever I am interested in. And finally, the agent, which agent is supposed to perform this task. So the agent thinker, which we defined over here, is supposed to perform this task. Okay. So whenever you are define it as, these are the three most important components that you have to define. First of all, description in greater detail how to accomplish this task. Okay, so for example, if it was a trading agent and if I gave it to analyze a stock, I will give it in more detail that hey, this is exactly how you analyze a stock and so on and so forth. Secondly, expected output. What is it supposed to output? Is it supposed to output in a single word that hey, there is a conflict or no conflict? Is it supposed to output and also give you the reason why it thinks it is a conflict or no conflict, and so on? So whatever you are expecting the output to be, you can specify it over here. And third is which agent is supposed to perform this task. Okay. So folks, is definition of a task clear to everyone? Just type in task in the chat. You can understand how to define a task in Crew AI. Just the basic parameters. Dots will connect, things will get more clear with the second example as well. But just get a sense of it, just get an intuition of it, how we're defining all of this. This agent is the most basic one that we can create. So we are not using any tools or memory in this. Memory is, you can just have a parameter for memory, which I will show you. It's very simple to use. Okay. Awesome. And finally, once we have defined our agents, okay, I have just one single agent over here, which is a thinker agent, okay, which can use this LLM. And finally, using this LLM, it will execute this task to detect a conflict. Then I've created a main file, which will just call everything and create this crew. So to create a crew in Crew AI, you will have to import from Crew AI, import crew. So just until here, you will see how the syntax is actually very simple to import anything in Crew AI. You have to define an agent, just do from Crew AI import agent. You need the LLM for agent. From crewai.llm, you can just import LLM. You have to define a task in Crew AI, you can just do from Crew AI import task. You have to define a crew in Crew AI, you can just do from Crew AI import crew. Okay, so that is where the syntax becomes pretty friendly. Secondly, to define my crew, which is a set of agents which are over here. In this case, there is only one agent, so we are still calling it a crew that you can do. The agent that I have defined over here named thinker, the task that I have defined over here named conflict task. Both of them I will also import from these two different scripts. I've created a separate folder named crew AI memory, which will be storing all my memory. Okay, to define a crew, you have a couple of important parameters. First is which agents are a part of this crew. In our case, we have only one agent. So we have written agents is only the thinker agent. Second, which tasks are supposed to be in this crew. So we have only one task, which is called as the conflict task. Whether you want to enable or disable memory, if you want to save things and save executions, you can just make it true. If you don't want to enable it, you can just set it to false. That is how straightforward it is to do that. And verbosity is equal to true or false. Basically means, do I want to see the intermediate outputs, like what are the outputs of the tool calls, what is the LLM thinking and so on, or I just want the final result. And based on all of this, I can just do a crew.kickoff and pass in this particular text. And this text will be populated over here in the task. And I can just print the response. Okay. So here we have just defined the agent in LLM. We have not used this agent. Here we have just defined the task. But how do you combine all of this together into one system and have it executed? You will have to define the crew for this. In the crew, you will define all the agents in your project, all the tasks in your project, whether you want your memory or not to be enabled. And verbosity is basically meaning whether you want to see the intermediate steps or not. Finally, you can just run your agent using crew.kickoff and pass on the inputs. Now, verbosity is very important. Let's say if I set it to true, which it has been for a while now. Let's say I set it to true and I run python main.py. Notice how the outputs will look like. Okay. So it is telling that this agent is there, no conflict is there. Finally, task completed, and final output is no conflict. You see a lot of these intermediate outputs. If you were using any tools and all of those outputs will also be here. But if I set it to false, you see, If I've set it to false, the response is directly no conflict. None of these internal thinkings, which agent was used, what was thinking, what was the input that was given, none of that comes. We just get our response directly. Okay. So folks, are these parameters clear to everyone? Type in clear in the chat. With the second and third example, a lot of this will make a lot of more sense. You will see patterns, but overall, are 70-80%, are you getting there? Okay, that okay, this is how we build an agent. This is a very simple example of an agent. From the second one, it will become a lot more real. Okay. Very good question has been come from Javeed, which is, can we use, can we basically dynamically assign tasks to agents? Yes, you can. You'll need an orchestrator agent for that, but you can. Okay. Quickly recapping everything that we have done till now. So we wanted to build a conflict detector. We wanted to build a conflict detector agent over here, which can basically take up any sentence. That sentence will go through an AI agent, which has its own error, and tell us whether there is a conflict or no conflict in the sentence. For example, this sentence hence has no conflict in it, so the agent should be outputting no conflict. To define this agent, we'll have to import agent from CrewAI and LLM from CrewAI. Then I define my LLM as OpenAI GPT-4o, set a couple of parameters. All of these are optional parameters other than the API. Even if you have just exported your API in the environment, none of this will actually be required. You can also pass on the AI model just over here, like you can just do a GPT-4o over here. So this also works. Just letting you all know. Okay. And then I've defined my agent, set up a basic couple of parameters for it. Once my AI agent is defined, what is the next step? To define the task that the agent will do. In tasks, I've imported it from CrewAI import task, define the description, what should the output look like, which agent will perform this task. Finally, when all of that is done, I will define my crew from CrewAI, and I will specify all the agents and tasks which are defined, and we are going to get our result. Okay, so this is it. This is under, I believe, 40 to 50 lines of code, and you have built your first AI agent. Okay. From here, the agents that we will see are going to be more application oriented. This was more towards getting you familiar with the syntax and how things are done. Now we will move on to something which is more application oriented, something that a similar version of that you can actually build in your work as well. And it will be a multi-agent system. Okay. Cool. Before we move on, folks, how is it going till now? Just tell me in a sentence, for the last 1 hour, how is it going for you all? Are you all able to follow through, understand why we are doing it, how we are doing it? Are you able to like have a great time? Okay. Is something? Are you all engaged enough? Are the explanations clear, and so on? Keeping up, good, engaged, highly engaged. Mostly what we have seen, okay. Mostly what we have seen for this particular session, this is one of those sessions where we have seen close to about 100% retention towards the end of like the 3 hours as well. Okay, so yeah, you will get more clarity, don't worry. But what I am able to sense from the chat, and folks, there are over 1,000 people on the call. Please be as active on the chat as possible. Okay, if you're stuck somewhere, if you're not feeling something which is right, or you are like, why are we doing this? And I see because I have separate monitor where I'm just monitoring this chat. So if I see a bunch of different people, you don't need to write the same question multiple times. I'm reading everything that is coming here in the chat. Okay. Yeah. So please, folks, please do not need to spam. I'm reading everything that is coming up. Okay. And I will be there till the end until all your questions are answered. But do not please spam the chat. Okay. But please be extremely active. I'm using cursor as my ID. Okay. I'm using cursor as my ID. It is a fork of VS Code actually. VS Code is I think most of you have actually used it. Cool. Moving on to the next agent that we have, it is going to be a DevOps agent. Okay, what it will do. I have a set of dummy logs over here. So whenever you folks program or if you have deployed things to production and so on, there are a lot of logs which come up. And when something goes wrong, it is first of all a little hard to parse through those logs, because sometimes even like when I used to, before Adobe, I was in a startup, and I used to maintain production code over there as well. The biggest issue I had over there was that the logs were too long. They're very descriptive, very good in nature. But if something has went wrong, it's not like I'll just find it in the last 10 lines of code. Last 10 lines of the log. I will have to literally dig into what exactly went wrong. And it would take a lot of manual time for me to figure out exactly what was went wrong. For example, I have taken like smaller logs over here so that you can actually go through this. Okay, let's say this is an example for dummy log where there was some database connection error. There some database retries were there. It was trying to my code was trying to connect to some database, but I felt some errors. There's some critical issues as well. Then there's an issue. Let's say that you're deploying in Kubernetes, and again some issues with the pod deployment. It was unable to pull some Docker image and so on. This is like 15-20 lines, but ideally in realistic scenarios, you will have like thousands of lines of logs. In that case, manually reviewing exactly what went wrong and all, and being able to fix that or revert to whatever commit you did before that becomes a very time consuming. And these are very critical situations which you need to handle very fast. Okay. So we are going to build a DevOps engineer agent. The DevOps engineer agent will have three different agents running together, one after the other. We will have a log analyzer, issue investigator, and solution. And finally, a solution specialist. Okay, so log analyzer, issue investigator, and solution specialist. So this is what it will look like. I will explain it to you. And folks, are these diagrams in the whiteboard being helpful for you all? Just type in helpful in the chat. Are these diagrams being helpful for you all? Yeah. Okay, cool. We'll continue that way only. Awesome. Okay. So this agent that we're going to build now, the second one is going to be a DevOps let me just do this. Yeah. Engineering agent. Okay. What would it look like? Initially, we will have a set of logs. Okay. So this is nothing but a log file like what I showed you. Okay. So this log file is going to look something like this. Whatever logs are there, this one or this one, either one doesn't matter. So there will be a log file. This log file will go through our agentic system. We'll go through our agentic system and tell us what are the things that we need to do. The first agent that we will have in this case, agent 1, is going to be called as log analyzer. We are not requiring any tool in this. This will just be an LLM, which will, what it will basically do, it will just take this piece of text. This will actually one tool will be required over here to read the files. Read. Yeah. So what this agent number 1 is going to do, it will take this txt file, log file, whatever kind of file that you have. Okay. It will read that file. It will use a tool to read that file. As I said, LLMs cannot read files on their own. They cannot read PDFs or whatever type of file that you're uploading. There has to be a tool which is actually helping them read those files. It will use this tool to read the file and let the LLM of the agent know that, hey, I believe this is what mainly the logs are looking like, and you can analyze this, figure out what are critical issues and so on. Once this is done, once it has figured out here that these are the issues, agent 2 comes into the picture. Agent 2 comes into the picture. Okay, so if I open up the agents, log analyzer is done, then we will have agent 2, which is the issue investigator. So I'm calling it the issue investigator. It will have access to a tool which can allow it to search the web or do web search for us, just like we humans do it. It's a way of talking we humans do it, as if we are like living in a world of robots. But yeah, So agent number 1 will be telling us that, hey Ishan, this is a log file and I believe these are the critical issues and these are possible actual set of problems. Okay, actual set of problems that are there that we need to solve for. Okay, that we need to solve for. All of this context will be passed on to agent number 2. Okay, agent number 2 will have access to web search. So whatever issues are there, whatever errors have been faced in the logs, it will search the internet for all of that. Okay, it will search the internet for all of that and figure out solutions to that, general solutions to this problem which people have come across. Once we are done with that, we will have our final solution specialist agent. Okay, we will have our agent number 3, which is called as a solution specialist. The tool, it doesn't require a tool actually, but there is one very important thing which is it is doing, solution specialist. Okay, this solution specialist not only takes inputs from the issue investigator, it will also take inputs from agent 1. Okay, what are these inputs? First of all, it tells us, agent 1 tells that, hey, this is the problem. Agent 2 is telling it, hey, these are the probable solutions based on our case. Okay, now the solution specialist will review the problem exactly figured out by agent 1, review the possible set of solutions. This is not the exact solution. This is just like if I give you an error statement right now, you will just go on Google and search for, hey, these are the probable solutions that are there. But agent 1 will have the required context to solve that problem. Both of this, the problem, exact problem, and the set of solutions which might or might not be able to solve this problem are given to agent number 3. And it is agent 3's actual responsibility to figure out a correct solution for this problem. Response, which is going to be solution on how to solve this particular problem. What are the set of, let's say, resources you figured out which are best in terms of solving this problem. Okay, so reviewing it again, we will have a log file which looks something like this. You can have any log file, you can just dump it from whichever instance and all you are using. That log file goes to a log analyzer, which will figure, it will have a file read tool. So you can't, it is a .log file. You can have a .txt file, you can have any form of file, you can have a .pdf or anything that you have over there. But the LLM can't read that. So we'll give it a reading tool, file reading tool. It will just take this text and put it to the LLM. Okay, this will figure out what are the actual problems. Okay, so these problems will be communicated to agent 2 and 3, both of them. Agent 2 is the issue investigator. Based on the problems that have been communicated by agent 1, it will go on the web. It has access to a web search tool. It will go on the web and it will figure out possible set of solutions that might solve this problem. It can go through GitHub, it can go through Stack Overflow, it can go through these articles and all. And finally, agent number of 3 will take in inputs from agent 1 that, hey, this is the exact problem. It will take inputs from agent 2 that this is the set of solutions, and it will finally be able to figure out. It does not need a tool for that. The LLM itself can do it. Finally able to figure out that, hey, this is the exact solution that you should be using for this particular problem. Okay, folks, is this flow of agents clear to everyone? Just type in flow in the chat if the flow of agents is clear to everyone. Flow is clear. Converting this to code isn't really the hard part. Okay. Do you know how easy it is actually for me to convert it to code? You can you can try it like in any of these things as well. This is not like a part where we do it, but for me to be able to convert this to code, I can just take a screenshot of this, put it on cursor, and I can ask it to refer to the Crew AI documentation. I have it indexed and generate the required agents, tasks, and crew to perform this task of a DevOps analyzer. Refer to the logs in the dummy logs folder. That is it. I just do it this much. Okay. I actually just do it this much, and cursor will actually generate the entire example for me. Yeah, this is just something extra, not what we are going to do today. But so I see a couple of questions. I'm just going over them one. Yeah, a couple of things where people might be stuck in. I'm taking these questions only because I feel a bunch of different people might be still feeling it. First of all, you might think that, hey, Shan, the logs are really larger in case. How will you actually feed everything? You don't need to. You can have a RAG-based system on top of it, which can feed it. So you can't basically feed thousands of lines of code. Instead of agents, can we just have prompts or LLMs? These LLMs, you will still have to give it. You will have to write your own tools in that case to access the text in this file, and you will have to write a tool which can access the web. The LLM cannot access the web for you. That is why we are using an agent over here. Okay, bundle crash logs. Yeah, Ashish has a very good point. Can we add like one more step where we have context of any of the previous crashes and all? That is where memory comes into the picture. So in my memory, we will have a lot of the previous logs as well. Okay, and if anything breaks in the flow, that's like a totally different thing. We will take all of that towards the end. Cool. Moving on, let's look towards the code for this. Okay. First of all, we will start with defining our agents. Now, in the beginner set, how did we define the agents? Just imported it from CrewAI, defined my LLM, defined a couple of parameters in the agent. We are going to increase the number of parameters that we are defining in this case. Okay, so we will see a couple of new parameters, and I will explain all of that to you as well. So don't worry about it. Again, same pattern over here. To define an agent, I have created an agents.py file. And you don't need to name it agents.py or main.py or task.py, anything of that sort. You can just name it whatever you want. But it is just a cleaner way to code. You can just define all your agents in a file, define all your tasks, tools, and everything in a file. You can have it in a Colab notebook. You can have it in a Jupyter notebook, wherever you want. Okay. So from CrewAI, I have imported agent. From CrewAI.llm, I have imported LLM. And in LLM, again, I have defined the same model, the GPT-4o. I'm using the OpenAI Router API key. Temperature I've set to a lot lesser now. Tokens and timeout is basically about 2 minutes. Okay, this is pretty much very similar to what we had already defined. Just reduce the temperature because I don't need the model to be creative over here. It has to be very definite and very to the point, and not exactly to the point, but there's no creativity required over here. You just have to figure out what is the issue in the log. So I've set it to low. If I would have been creating an agent as a script writer or story generator, I would have probably set it to about a 0.8 or 0.9 or something. Okay. Secondly, all three of these agents, you can think of it in this way. All three of these agents, log analyzer, issue investigator, solution specialist, are specializing in one particular task. But at the end of the day, they are all a part of a DevOps engineering agent. Okay. Am I audible? Oops.
Yes.
Am I audible, right?
Yes, yes.
Yeah, cool. So, yeah, cool. Got it. So look at it this carefully, and it's extremely important to understand that these three agents, log analyzer, issue investigator, as well as solution specialist, although these are three separate agents and have their own specialized tasks, but at the end of the day, they are a part of a larger ecosystem, which is for a DevOps engineering agent. Okay. So do you think there will be some things which are common between these three agents in terms of prompts and some things which will be making them specialists? Okay. Just type in yes in the chat. Like, let's say as an engineering team, okay, for example, as an engineering team, there are some principles which are common to everyone, all of you. There are some coding standards which are common for them, regardless of you're a front-end engineer, you are a back-end engineer, anything that you are. Okay, regardless of all of that, whatever you are actually doing, you'll have a set of common things in terms of system prompt. Okay, that is what we call as a system prompt. I'm not talking in terms of parameters, but I'm talking in terms of the prompt. Okay, so let's say in this case, I have a system. I have defined a system template for DevOps. This will be passed to all of my agents. This will be passed to all of my agents. And folks, writing the correct prompt, writing the very accurate prompts is extremely important. It can be the maker or breaker of your agentic systems. So you have to be very careful on how you are writing it, what you are writing, and so on. Like in this case, I have written it very clearly in bulleted points as well as in numbered lists, and so on. Okay, so in this case, I have written that you are an expert DevOps engineer with extensive experience in experience in infrastructure automation and orchestration, container technologies, Docker, Kubernetes, CI/CD pipelines, monitoring, logging, observability, cloud platforms, security best practices, and compliance. Always provide. So all of these three agents are always supposed to provide a detailed technical analysis, step-by-step solutions, best practices and recommendations, any risk assessments, and references to official documents only. So because we have agents which are referring to solutions and issue investigations, web search and all, I want you to not refer to some random articles on the internet, but refer to original documentations and focus on practical production ready solutions. Don't give me solutions like restart the system. Okay. So this template will be passed on to all of them. Okay, so there is a parameter which is called a system template, and the same parameter has been populated to all of my agents. Okay, to all of my agents. Now, folks, there are a lot of parameters. Don't worry, I will explain all of them to you. Some of them are common, like role, goal, LLM, and backstory. In terms of tools, we have another extra parameter over here. Verbosity is there. We have max iterations. We have max requests per minute, and we have max execution time. Okay, what are these parameters? These are extremely important and very crucial in building such agentic applications. Okay, to quickly take you through what are these parameters. Okay, and these are very important. So please keep in mind. Okay, so we have three parameters which we are going to talk about over here. Okay, the first one is going to be let's say max iterations. Second one is going to be this one, max execution time. Max execution time. And third one is going to be max RPM or max requests per minute. What do all of these mean? Max iter stands for maximum number of iterations. Okay, what does maximum number of iterations mean? If I give you a problem to solve today, okay, let's say your manager comes and he gives you that, hey, Ishan, there is this one particular problem which you have to solve. Do you think, and I'm not talking about extremely easy problems, intermediate, moderately complex problems, do you think you can just attempt it in the first go and solve every problem that you get in your life? Again, like, I'm talking about life, but in terms of code, let's talk about code. Do you think at just the first go? There are chances where you will be, okay, but most of the cases you will have to reiterate a lot of times. So you came up with a solution, you discuss it with a couple of people in your engineering team, you discuss it with your manager, and so on, and you get some feedback. Based on that, you improve on top of it, and so on and so forth. So you run through multiple number of iterations for that. Similarly, when an agent is actually doing something and you have given it a problem to solve, do you think it can go through thousands of lines of code and just give you an analysis that, hey, these are the 5 set of problems just by iterating it through once? It cannot. It will have to go through it multiple number of times. And yes, the code will be given to all of you. Please don't worry about that. Okay. So it will have a very hard time, right? If I give you 1,000, just think of it for a second. If I give you 1,000 lines of logs and ask you that, hey, you can just read the log once and you'll have to tell me exactly what the problem is. Sometimes you will be able to, if it is very clear. A lot of times you won't be able to do that. So you have to go through that multiple number of iterations. But there has to be a limit to that. Okay, I can't be like that, hey, you have unlimited number of iterations that you can go. With every iteration, you are using an LLM call. And with every LLM call, there is some cost which is associated. It is not for free. Okay, so maximum number of iterations tells us the maximum number of times. Let's say there is an AI agent A1. Okay, how many times can it actually iterate over the problem? If I set it to only 1, it can only go through whatever we have given it input and all once, and it will have to give us whatever response it has generated. Ideally, depending on the kind of problem that you're doing, it is set either between 3 to 5, depending on the kind of problem. So that is maximum number of iterations that you're allowing the agent to do to solve a particular problem. Okay. Second one, max execution time. Okay. Let us say one of these iterations takes 5 minutes. Second one also takes 10 minutes. Third one takes an hour. And this is a system which you have deployed in the production. Do you think it will be very feasible to wait till the best possible perfect solution comes up from your agent after 2 hours and then you fix your production code? Do you think that would make sense? Ideally, what people would do is revert a commit, or they will send a quick fix. Okay, which you will send a quick fix on your GitHub repository or your code, and finally, you will be when you have actual time, then you will look for like what is a actual solution, right? So what max execution time sets is max time. Okay, it is max time which the agent can take to solve a problem. And this has higher precedence to max iterations. So if I have set max execution time to, this is in seconds by the way, to 60 seconds. Let's say max execution time is 60 seconds. Okay. Max iteration value is 3. Okay. And every iteration is taking you about each iteration takes you about 30 seconds. If maximum execution time has a higher precedence than max iteration, which basically means if max execution time gets hit first, it will stop the execution regardless of the number of iterations you have left. Okay. And let's say in your project, you have specified max iterations to be 3. You have specified max execution time to be 60 seconds. On an average, every iteration is taking about 30 seconds. What is the actual max number of iterations that your agent can do? We have set it to 3. We can also set it to 5, 10, 15, whatever we want. But given we have a hard stop of 60 seconds, and on an average, each iteration can only take 30 seconds. What is the maximum number of iterations the agent can actually do? Okay, right. It will be 2. Why is it 2? First iteration took 30 seconds. Second iteration will take again 30 seconds, which will be a total of 60 seconds. As soon as we hit this, the max execution time parameter will be triggered and the execution will be stopped. It's just like when you actually give an exam. Okay, when you're actually given an exam, let's say it's a 3-hour exam, regardless of the number of problems that you have been able to solve in those 3 hours, at the end of the 3-hour exam, it is a hard stop and you have to submit whatever answer you have. Okay, so that is max execution time. Folks, is max iteration, okay, we'll blow that again. Okay, but I think it should be clear to you till now what is max iterations. Number of times the agent can think or iterate on the same problem. Max execution time, the maximum amount of time the agent can take to process your request. And RPM stands for requests per minute. Okay, what is this? So within these agents, we are using APIs, right? APIs for LLM calls. We can also have APIs for tool calls like web search and so on, and a bunch of different APIs. Now, each of these APIs have something which is called as a rate limit. Okay, what is a rate limit? A rate limit basically means that, hey, even if you have the OpenAI API key, even if you have the OpenRouter API key, it does not mean you can make infinite number of requests to their server or to their system just because you have that particular key. You will be rate limited. Okay, so each of these APIs have their own rate limit. So depending on which API I am using, which tools I am using, and so on, I can set a parameter which is called as requests per minute. So let us say OpenAI only allows me to make 2 requests a minute. I cannot send more than 2 requests a minute. So what I will have to set, my max RPM, I will have to set as 2. Okay. If I am not setting my max RPM and I continuously keep on sending OpenAI requests for LLM based queries, it will end up rate limiting me and maybe also throttle my responses. Okay, so that is why max RPM, which is requests per minute, is required. Okay, quickly summarizing what we covered. Max iterations, every agent needs to go through multiple number of times to the problem that you have given it to solve. And by every, I mean each of these. It can go through log multiple number of times. Issue investigator, it can go through the web multiple number of times to figure out the actual solution. Solution specialist can go through the problem and solution multiple number of times to solve your problem. Now that is limited by maximum number of iterations is what is the time I can set for each agent to take the maximum number of iterations. Max execution time is each agent, what is the total amount of time it can actually take. Okay, and max execution time has a higher precedence than max iterations, which means if max execution time is hit, regardless of, let's say, even 10 more iterations are left in max iterations, I will still stop the process for the agent and move on to the next step. And max RPM is more towards the API rate limiting side of things. It stands for requests per minute, and you set it so that you don't get throttled by these different APIs that you're using. Okay, folks, are these parameters clear to everyone? Just type in params in the chat. Just type in params in the chat. Are the parameters clear to everyone? These are parameters which you will see across multiple different agents, multiple different frameworks that keep coming up. Awesome. Cool. Moving ahead, let's get to the code now. The code will become a lot easier for you all now. Okay, so we defined the system template, which is common to all of our agents. We've passed it to all. Now let us define one by one the agents. Okay, and I will go through each of these, so don't worry about it. Okay, first of all, role. Who is the agent? Agent number one is the log analyzer, which will actually be reading this log for the first time. Whatever log we have, will be reading this. So I give it the role of a DevOps log analyzer. What is the goal? What is the agent supposed to accomplish? Analyze the log files to identify and extract specific issues, errors, and failure patterns. Okay. What is the LLM it will use? LLM has been defined over here from Crew LLM, imported LLM, OpenAI GPT-4 with the Open Router API. Okay, so LLM is defined. Backstory. See how detailed the backstory now starts to get. And once you see the backstories of all the three agents, you will see how I've made them a specialist of whatever they're doing. For log analyzer, the backstory is you are a senior DevOps engineer with 10 years of experience in analyzing production logs and identifying critical issues. Okay. See how I've made it very clear that you are someone who is very good at identifying critical issues from logs. You excel at parsing through complex log files, identifying error patterns, extracting relevant error messages, and determining the root cause for failures. This entire backstory is tailored into making it a very good log analyst. Instead of that, if you look at the issue investigator, in this also we call it as a DevOps. You're a DevOps troubleshooting specialist who excels at quickly finding solutions to technical problems. You know how to search effectively for similar issues, identify reliable resources, gather comprehensive information about error patterns and their solutions. You see the difference between this backstory, which is just to analyze log files, and this backstory, which is creating an issue investigator agent, which can identify similar patterns, similar issues, and consolidate everything. And finally, the third solution specialist backstory will look like you are a DevOps solution architect who specializes in creating a reliable step-by-step remediation plans for infrastructure and deployment issues. You always provide official documentation references, tested solutions, and preventive measures to avoid future occurrences. Folks, are you able to just follow through the backstory of these agents now? Just type in backstory in the chat. Do you see the difference in the backstory? How, first of all, this system prompt is kind of ensuring that every agent is kind of similar in the kind of outputs it gives. But with the backstory, I've made everyone a specialist. In case of log analyzer, I have explicitly mentioned that, hey, you're very good at analyzing logs and identifying critical issues. In case of issue investigator, I've made it very clear that you're very good at finding solutions to problems, finding similar issues, referring to reliable resources. In terms of solution specialist, I've made it very clear that you provide step-by-step solutions, provide official documentations, and so on. Okay, backstory is clear to everyone? Amazing. Now there is a parameter. Okay, there is a parameter which is called as tools. I will show you the tools implementations as well after this. So in tools, the log analyzer will only use the log reader tool. Okay, so if you see the diagram, log analyzer uses one tool, which is to read. We will set verbosity is equal to true so that I can see the intermediate outputs. In this case, I've set maximum number of iterations to 3, and I have set maximum requests per minute to 10, more than generous to solve this problem. Set enabled memory is equal to true. In my logs, you might see some errors because there are some, we actually got rate limited by OpenAI last night. Right, so and the memory function of 2AI works with the OpenAI API key, OpenAI API. So just ignore those errors for now. I have some more memory logs which I can actually show you. Passed on the system template, maximum execution time is 300 seconds, which is basically 5 minutes. Okay. Respect context window is equal to true. Every LLM has a context window. Generally today, most LLMs, it's around 100,000 to 200,000 tokens. And I've asked it to whatever you are doing, just be within that context window. Don't exceed that. Okay. So you see a role. What is the agent about? Goal, what is it supposed to accomplish? Which LLM will do it? Backstory, make it more personalized, make it more specialized. Tools, which tools it can use. Verbosity is equal to true, means I want to see the intermediate outputs. The agent can iterate over this particular log file only 3 times. Maximum requests per minute, it can make only 10 total requests to the open router API that we have passed. I want this execution to be saved in my memory. Passed the system template. Maximum execution time, this agent has a maximum amount of 5 minutes only to solve this problem, regardless of how many ever iterations are left, and keep within the context window. Second agent, issue investigator, DevOps issue investigator, what is it supposed to accomplish? Investigate identified issues by searching documentation, forums, and known solutions. We have already gone through this. Again, these are just some parameters we just said. Now, this issue investigator agent, if you see, it's a more complex problem than just being able to analyze the log files. So here, when I have given max iterations as 3 and max requests per minute 10, I've actually increased it over here. So from 3, I've increased it to 5 because it will take it a couple of more times to search the web. And max requests per minute, it might just need to call OpenAI or OpenAI as well as it using a web search tool as well. So 2 different APIs are involved over here. So I've increased the value over here. Again, memory is true for this agent, pass on the system template. And again, because I have increased these parameters for max iterations and all, and it is using something to search the web, it is then sending it over to OpenAI to call something, it will require more time. So I've given it 10 minutes of for thorough investigation. And again, respect context window to 2. Finally, our solution specialist, DevOps solution specialist, provide clear actionable step-by-step instructions based on investigation findings. Max iterations is 4. For this, I think 3 will also do for this. Request per minute is 8. Memory true. System template. Execution time is somewhere in between the first and second agents. Again, these are things that you see on a trial basis as well. Like you will try with a couple of different parameters, play around with that and figure out, hey, this is working best for me. There is no hard set of rules. I can only be logical in this, like reading a log and figuring out an issue is a easier problem as comparing to going on the internet and searching for solutions to that problem. Hence, whatever parameters I have set over here, I have increased that over here. That is the kind of logic which I follow. And again, you try it a couple of times and you figure that out. So this is how the agents have been defined. We have covered each and every parameter. How does backstory differ? What are system prompts? What is max iterations, max requests per minute, memory, system template, execution time, all of that. Let me show you the tools. Okay, so we are using 2 tools over here. Agent 1, log analyzer, uses a file reading tool. Agent 2, the issue investigator, uses a web search tool. Okay. Now these tools are defined in the tools.py file. In the tools.py file, first of all, there are 2 forms of tools. The first form is called as inbuilt tools, which the library itself provides you. Okay, and the second form is called as custom tools, which you have to define on your own. Okay, there is not a possibility that any framework out there will know exactly, hey, Ishan is creating such kind of products, I should create such kind of tools. Okay, no one can give every form of tool for you. You will have to code them up yourself. But there are a lot of common use cases, like web search is extremely common. Okay, so a lot of these frameworks give you inbuilt tools to use that. For example, the inbuilt tools of CrewAI are available in a package called as CrewAI_tools, which you'll have to install separately. You will import ExaSearch tool and file read tool in this. ExaSearch tool is a web search tool. So if I show it to you, you go on Google, type for ExaAI. Interestingly, one of my ex-colleagues actually works here in the company, and they recently raised like a really good round, I think $70–80 million in their series. So it's a very good tool. It is actually a search engine which is optimized to be used by AI agents and similar RAG systems and all. Okay, so instead of just using a Google API or a similar API for web search, we prefer using something which is optimized for agentic use cases. Exa is one of them that we use. Okay, so that is also the implementation of this tool, calling how it will call and all of that is done within CrewAI tools itself. Secondly, we will need a file read tool. This is a very simple tool. You can just give it any file. It will just copy the text and paste it in the LLM. Okay. Now, initializing the tools is pretty straightforward. I have imported the tool from True AI, and I have just called it and created an object out of it, the log reader tool. You will need an exa API key for the web search, but the exa API key, there is like a very huge free limit for this. I have never had to pay for this till date for some context. And you can just do it with exa search tool. There is just some error handling which is there. But to define a tool, you can just import it from True AI tools and you can just call it and create an object out of it. Literally like 2 lines of code are required, importing it from True AI tools and calling it as an object. Now, once I have defined these tools, log reader tool and exa search tool, I can call them over here from tools import exa search tool and log reader tool. Just type in tool in the chat if you're clear how to define inbuilt tools. Okay, how to define inbuilt tools in True AI. Just type in tool in the chat. Pretty straightforward. In the next example, we will also see that, hey, if I want to build a tool, okay, if I want to build a tool and that is not available in True AI or any of these things, how am I actually going to implement that? So we are going to create such tools which are not available over here in True AI or any other frameworks, and we will see how we can pass them as tools as well. Okay, cool. Let's move ahead. Okay. Now we will define our tasks. Tasks in this case, it's mostly about prompt engineering over here at this point. Couple of things that you will need to define tasks. First of all, from True AI, you will have to import task to define the task. And you will need to, with every task, you will have to specify clearly which agent is doing it. So in agents, the 3 agents that we have defined, log analyzer, issue investigator, and solution specialist, all of them we import here in the from agents. Okay. Now we will just write some very clear prompts for this, like analyze log. Analyze the log at the file path. We will populate this, but this is a variable over here, and we will populate it with whatever the file path is to identify and extract specific issues. This is how exactly you should be going, identifying error, critical warnings messages, determine timeline of events as well, identify root causes, and expected output is going to be detailed analysis. What is the primary issue that is there in the log, key error messages, what is the timeline of failures, root cause analysis, and so on. The agent that we will be using it to perform this task is called as a log analyzer. There is a very important parameter in the task which is called as an output file as well. You can use this output file to dump the outputs of this agent. Okay, so if you want to go back to it later, you can just open this particular file and it will be available over there. Second, investigate issue task. Just tell it how to investigate, like search for similar errors, find only in official documentations, look for community solutions, identify common causes, gather information, and so on, and focus on finding reliable, well-documented solutions. Expected output, similar issues, official documentation, common causes, best practices, and so on. Which agent will do it? The issue investigator. Now, here is something very important. You see this connection between agent 1 and 2 going from log analyzer to issue. And I said that agent 1 will figure out the problems that are there and will pass it on to agent number 2. But how is this connection actually made? It is not made at the agent level, it is made at the task level. Okay, so in task number 1, which is analyzing logs, once this task is completed, I will have a set of the primary issue and what is the actual cause of this particular failure. I can take the context of this task, analyze log task, and there is a parameter for this, which is called as context, and I can just pass it on over here. Okay. Similarly, as I said, agent number 3 will have the context from the log analyzer and issue investigator. For agent number 3, in terms of solution task, in context, I will pass on both of them, analyzing log task and investigating the issue. So these exact lines that you're seeing, the connections that you're seeing, are done in this manner. Okay. Similarly, it's just more or less just a lot of prompt engineering. And solution, I'm asking it to create a step-by-step solution, provide verification steps, monitoring preventive measures, and expected output is primary solution, configuration changes if there are any alternate solutions if they are possible, what is the rollback plan for this issue, links to official documentation and references. Okay, so folks, just type in task in the chat if you have understood how we have defined these tasks. It's mostly about writing in detail how that particular thing will be provided done, exactly specifying which agent is supposed to perform this task, context providing, basically creating these connections, which agents outputs will go to which agents, okay, and if you want to save the output like in a file as well, so you can do that, okay. Cool. Now, once we have defined our agents, we have defined our tools, we have defined our tasks, we can directly go and create a crew now. Now the word crew will make a lot of sense because we have three agents together. Quickly tell me one thing. These agents that I'm running, um, can I run these agents 1, 2, and 3 in parallel, or I will have to run them in sequential order? Type in parallel or sequential based on whatever you think. Can I run 1, 2, and 3 in parallel? Of course, if you want, you can run, but does it make sense to run them in parallel, or we have to run it in sequential? Why do we have to run it in sequential? Okay. Correct, because their output, the input of this agent depends on the output of the previous agent. You can't run these agents in parallel. It does not make sense. You can't search for solutions on the internet without knowing what was the actual cause. Okay. You can't start generating solutions without actually knowing what are possible solutions, what was the problem, and so on and so forth. So we'll have to run this one after the other in sequential manner. Okay. So to define the crew, from crew here I have imported crew and process, and to mention that hey, there are multiple agents but I want to run it sequentially, you can just specify process is process.sequential. This is also a default parameter, so in the, even if I don't specify, whenever I remove this, the value of process will be process.sequential only. I've just kept it to show you all over here how that works. So in process you can just do process.sequential. There's another type of process in crew which is called as process.hierarchical, wherein you could have had one agent over here which could control multiple different agents and their outputs. Okay, but that will be like too complex for today. Okay. Now to define my DevOps crew, in this case I have three different agents. So I've defined all the three agents over here. I have three different tasks, each corresponding to one agent. I've defined all the tasks. Verbosity is equal to true. I want to see the intermediate outputs. I want to see, I want to keep the process sequential. I want to keep the memory as true. I want to keep output caching as true because there is a lot of web search which is happening. So if I am looking up for similar issues, let's say similar kind of, we have logs on Kubernetes, right? So let's say another Kubernetes issue came in. So I won't be doing the same web search again. I will just use the cached one, and max requests per minute. So you can set a request per minute. You can set these parameters which I mentioned over here, request per minute, execution times, max iterations, all of that. You can either mention it at an agent specific level that each agent can take this much time or these many requests, or you can also actually have a global limit to them. Like even if let's say agent one, let's say agent one has an RPM of 50. Okay, agent 2 has requests per minute 50, agent 3 also has 50 requests per minute available with it. So total is 150 requests that they can make. Let us say the execution time is very high. They can actually do these numbers. But my crew is limiting it to 30. So if I am reaching 30 requests a minute, it will automatically limit these. This has the highest precedence amongst any of the agent that you are defining. And finally, you can just do crew.kickoff, pass on the path. So in this case, let's say I'm using the Kubernetes one. So I've just passed dummy logs / Kubernetes. And let us see the error first. Error was something about, okay, this app failed to start. It is trying to pull some Docker image ideally, but it is unable to pull it. Okay. So let us see what kind of solutions we can come up with. I will navigate. And I can just do Python main.py. Let us see. Okay. So there is already some memory over here. You can see CrewAI memory folder is created. Okay. And which is doing that. This error that you saw over here, where is this? Okay, it went away. Interesting. Yeah. So it has retrieved some memory from our past executions. This is the amount of time it is showing me, that how much time it took to retrieve that. This is the historical data. Agent has started. The first agent is the log analyzer. This is the task it has been given. Execution has started. It is taking in the tool input. Now see, interesting thing over here. As I said, what does the file read tool do? The input to the tool is just the path of the file. The output of the tool is just the contents of what were there in the file. That is it. Okay. This is now in the form of text or string. You might call it into input to file reader tool was just the path. Output is whatever text content was there. Okay. So that tool is done. DevOps log analyzer is telling me primary issue is the failure to deploy the application due to inability to pull the Docker image, resulting in deployment error. Key error messages, it gives me what are the key error messages. Timeline of failure, like deployment started, pod creation initiated but entered pending state, failed, and so on. And a root cause analysis also it gives me that it is inability to pull this Docker image due to access issues. Message indicates image repository does not exist or like requires authentication, something like that. Any relevant context that it has given us, Kubernetes deployment configuration, Docker image, these are things which you can actually refer to. Okay. So that is there. So that first task is completed for DevOps log analyzer. And again, we start with the second task, retrieve some memory for the second task, and the issue investigator. Okay, this second one comes into picture. Now this issue investigator, we will use the exa search tool, which is to search the image. Image, I'm saying it search the web. Okay, and it will look for this search query, like fail to pull this image, unknown error, and so on and so forth. And you can see the tool output. So the exa search API gives us a bunch of different URLs. You can just access any of these URLs and what issues are there. Live access also goes to Stack Overflow. Like if I just take in any one of these URLs, let's see what it is looking for. I will just copy this. And this is figured out by exa search, like not by me. Okay, full access denied to repository does not exist or may require Docker login. So it is going through, it is getting all the context from there. Okay, and it's telling me that hey, the issue investigator figured out similar issues like Docker engine error, programmer's article, some where it has Stack Overflow discussion, Alibaba FAQs and all, and the links to all of them. Okay, official documentation links, community verified solution, best practices, and so on. So you see the log analyzer has figured out exactly that this is the problem, exact problem, timeline of failures, and this is the root cause. Then the issue investigator has actually looked up the internet, figured out similar errors, and given us a lot of context that we can use to solve this problem. Now this task of issue investigation is also completed. And finally, we run our solution specialist. Okay, solution specialist will be taking input from both the agents about the problem and the probable solutions and gives a step-by-step solution. So it gives us multiple different options. Like first of all, starting with something as simple as check the Docker login credentials with the commands, check the repository name and existence, if that Docker repository is even existing or not. Update the Kubernetes deployment with full secrets. It has also given us the exact code that you can do, or you just redeploy the application. Any configuration changes that you can do, any verification steps that you can do to verify whether this actually fixed something or not, and alternative solutions like you use public Docker registry, use Kubernetes service account, and any other prevention strategies and rollback plans. And all of that has been done. And all of these outputs are also saved over here in the analysis. So if I just go on the solution plan, I save this in Markdown format. Okay, I opened it twice. So this is what the remediation plan will look like. Okay, with exact code, what you need to do, how to redeploy, verification steps, alternate solutions, and all of that. So this was your DevOps engineering agent. Folks, are you able to understand now why I have used separate agents for everything? Are you able to figure that out now? I could have used, some of you might think that, hey, Shan, why not just one agent for the entire task? Okay, why not one agent for the entire task? I'm not using that for the entire task. It's because I want to make specialist agents. The more specialized your agent is, the better its output will be. It's like saying that I will have only one engineer in my team who will do front end, back end, DevOps, all of that. He might know all of that, but he might not be exactly a specialist in all of that. In our case, we have a specialist in terms of figuring out what is the exact issue in the log. We have a specialist who is very good at searching the internet for similar issues, and we have a specialist to given a problem and probable set of solutions, it can give us the final solution. Okay. And this was your DevOps engineering agent, where we started with a log file, passed it on to a log analyzer, figured out solutions on the internet, and finally got our solution. Okay, folks, were you able to follow through this example? There was a lot more in this than the first one that we did. Just type in DevOps in the chat. Just type in DevOps in the chat if you were able to follow. We still have 100% of the people who have, like since morning, it's been 2 hours. So I feel a lot of you are decently engaged enough and are able to follow through. Okay, how is it the session going till now? Okay, we have done 2 projects. We've done a baby project to get understanding of parameters and conflict management and all, how to use these LLMs, basic how do you set up this project and all. Second one, we did a multi-agent system, but we are running things in sequential. Now the third project, we will have a multi-agent system. We'll have multiple different tools, and we will be running these agents in parallel as well. Okay, how is it going till now, folks? Awesome, great. What we will do here, the third example is a little more involved, okay, and there are a lot of new things that you will be able to learn till there. If you have liked it till here, you will be going to love that third agent that we're going to build. That will be a stock trading agent. Okay, so what that agent can do is what that agent can basically do is you can just give it the name of a stock. That is it. You'll have 4 different agents. You just give it the name of a stock. It will figure out bunch of things around that agent, which I don't want to reveal it right now, but bunch of things around the stock which is important to make a decision trade. And finally, there will be an agent which will tell us that whether you should buy this stock, hold this stock, or sell this stock. Some additional things that you're going to learn in this one. First of all, how do you implement custom tooling? Okay, so for example, in this case, if I go to tools.py file, I've just imported the web search tool and file reading tool from CrewAI. But CrewAI or any other framework, as a matter of fact, does not have every tool on earth to run things from. Okay, so how does that how does it go about? So if I have to define something custom of my own, like so I will define some finance tools of my own, and I will show you, okay, I will be showing you how you can actually pass them as tools to CrewAI. Secondly, we will also learn how to run these agents in parallel and a bunch of other things as well. So what we will do is we'll just take a quick 5 minutes of break over here. Om, are you there on the chat? We will take quick 5 minutes of break, and then we will resume with the third project, as well as what we will do is I will also give you a roadmap at the end of it, that after today's mastermind, what is it that you can actually do to upskill and what path you can take. Okay, so yeah, we'll just be right back.
Perfect. Folks, we'll get started in next 5 minutes. We'll get started with the break, and also I'll just put in a timer here so that we know when we have to come back. Okay, give me just one quick second and we should be set.